And welcome back to SN Tutors. Today we're going to be talking about bent molecular geometry. The two that I want to go over are the 120 degree bent and the 109.5. So first thing you'll notice is that 120 here, that is usually the angle for the trigonal planar geometry, right? And 109.5, that's a 5, is usually the angle for the tetrahedral, right? And it's good that you notice that because that's exactly where it comes from. So let's start with the 120, right? So if we think about an atom that has three things surrounding it, right? So let's call it A. Don't worry, it's not an element. But it's got three things. This is the 120, right? But let's say if we turn two of those things into atoms, but one of them is a lone pair, then our molecule is just this part right here, right? And that's just electrons, so you won't see an atom there. So that's how you end up with bent. A good example of this, real quick, good example is SnCl2, right? Because SnCl2, Cl only bonds once because it's a halogen, right? But Sn still has this lone pair up here, right? So it won't be linear because of the repulsion that we have here. It's actually going to be bent 120. So that's when you have trigonal planar electronic geometry, but one of them is a lone pair. So you end up with bent 120. How do you get bent 109.5? Well, using that same logic, that would be for when you have a tetrahedral molecule, in terms of electronic geometry, tetrahedral electronic geometry, right? But in this sense, two of them are lone pairs, and you're going to end up with bent 109.5 being right there. So the classic example for this one, classic example here is going to be water, right? Because water, oxygen, actually has a valence value of 6, so it's going to have 6 lone pairs, right? So real quick, let me just show you. It has a lone pair here, or actually I'll put the lone pair, I'll put the H here, right? Because H2O, right? And then we're going to put the other two lone pairs here and here. So now, although it has tetrahedral electronic geometry, the molecular geometry is bent 109.5, with this angle being 109.5. And that's how you get two different molecules that have the same name for their geometry, but two different angles because they originate from two different electronic geometries, right? 109.5 comes from the tetrahedral electronic geometry. 120 comes from the trigonal planar electronic geometry.